Okay, so good morning and good Monday, everyone. Welcome to the chapter 5 of the DHC Plus Innovators webinar series. It is a pleasure to have you with us today, and I hope you're looking forward as much as I do for the presentations and for the discussions of this fifth episode. Today, we're going to talk about the name actually is from design to optimization, digital intelligence for next generation heat networks. So the topic explains itself. It's about digitalization and how new technologies can help district heating and cooling become more efficient and more sustainable. You're probably estranging the different speaker today is because Gabriele could not make it, so he asked me to substitute him. So in case you don't know me, I am Evan Bernardi. I'm a project officer at Euroheat and Power, and I'll be moderating today's event. Just a few explanations. It's very important. This webinar is being recorded, so all of the presentations as well as the recording will be made available after this event ends. And also, I ask you if you have any questions to our speakers today to write in the Q&A box, put your name and the name of your company. So after all the presentations, we can have a nice Q&A session, a nice exchange between the audience and the speakers. So let me explain a bit more of what we're aiming with today's webinar. We are all aware of the challenges facing the energy sector, right? So Europe needs urgent answers to its dependence to fossil fuels. And in fact, last week, the EU Commissioner for Energy, Dan Jorgensen, he put very clearly this challenge we have when he said that since the war started in the Middle East, the European Union taxpayers had to pay additional 3 billion euros for fossil fuel imports due to these price shocks. So it comes as no surprise that digitalization and use of smart tools are key weapons we have uh, to turn district heating and cooling networks into efficient systems, optimizing energy production, supporting the planning of fourth and fifth generation grids, and more accurately identifying and solving problems in the systems like leaks and drops in pressures, for example. So to discuss how digitalization can positively contribute to a decarbonized and intelligent networks in the future, I have with me today representatives from two companies specialized in digitalization and data analysis for DHC, Planeto and Optit. They will talk more about the current scenarios and the breakthrough technologies enabling smart district heating and cooling networks. So let me explain a bit what these companies do and what makes them so important for the future of DHC. So first, Planeto is a University of Geneva startup. Their flagship product is TESSA, which means Thermal Energy System Simulation Assistant. It's a user-friendly, web-based energy planning software that makes DHC networks planning faster, more efficient, and more accurate, and more cost-effective as well. TESSA automates the planning process while also supporting collaboration and feedback around projects. On the other hand, we have also Optit, which was founded in 2007 as a spin-off of the University of Bologna and develops and supplies decision support systems based on mathematical modeling, operations research, and data science. They support business and industrial customers in making the most of their data to optimize design and planning from long-term investment planning down to day-to-day operations. So a very brief explanation of the companies and the topics. I think the most important part now is to let the speakers present their part and better dive into today's topic. So I invite now to present Stefano Cozza, which is an energy engineer with a PhD in environmental science, specialized in building energy efficiency. He founded Planeto to drive decarbonization through science and innovation. He's passionate about sustainability and outdoor sports. He brings technical depth and technical approach to solving climate challenges. I give you the floor now, Stefano.
Thank you. Thanks, Ivan. So I think, okay, perfect. So thank you. Thank you, everyone. Okay, this did a bit of skip, but okay. Wait, let me see. Perfect. So few words about us, about Planeto. But yeah, you said already enough. So yeah, we are a spin-off of the University of Geneva. We are based in Switzerland. And we really focus in developing software solution for the decarbonization with a focus on district heating and cooling networks all the way from the feasibility study to the design and engineering and construction of the networks. But more than, let's say, the things, what we are is more the things we do, the solution we provide, the technology we work on. Today, focus of the webinar was more on new generation district heating. So I thought it was maybe useful to be all on the same page and have a little introduction on the technology we work. So as we know, over the time, district heating changed a lot, passing from, let's say, the first generation to fifth generation, the one of today network. And what is changing over the time is, of course, increasing the efficiency of the network, reducing the temperature into the systems, the possibility of integrate cooling and more renewable resources, and all these making network that are also called energy networks or low temperature networks that can work at ambient temperature, can provide heating and cooling, can use different amount of renewable resources with seasonal storage, waste heat, water, data center, really integrate different solutions to provide heating and cooling to the buildings. And this is a solution that we see developing very fast, or at least a bit faster than, let's say, classic big project district heating. This because exactly our networks that are a bit smaller gives the possibility to really use local energy resources that are really specific to every place. And can connect less buildings, so they are able a bit to overcome a lot of the classic problem that we have with big project of district heating in cities, in which we need to close many streets, connect many buildings, need a lot of financials to make it work. So it's really a solution that that can work and that is working very well for many European cases. So it's a solution that seems the dream one and that could be deployed very, very easily and very quickly. But of course, it comes also with many challenges, as you know, of course, with all this increasing inefficiency in more renewable, more complex is the networks, and the higher are the challenges. So we need to better identify really the building demand. We really better identify the part of the supply. The renewable, as we know, are not always available. Buildings are all different. So all this comes with a lot of challenges, and a lot of challenges that can be partially overcome with software and digitalization. So that's the focus of our work, is really to bring a digital tool and digital solution to overcome many of these technical challenges engineers and planners are facing when designing district heating network. And this is also why we develop, as Ivan was saying in the introduction, our software TESSA. This is the Thermal Energy System Simulation Assistant. TESSA is a software that we started developing almost 10 years ago in the University of Geneva with my two co-founders and colleagues, Jonathan and Xian. We were all working on different topics of energy efficiency. So we were working on the thermal networks with algorithm to cluster the buildings. We were working on energy models. We were working on climate science and climate scenario, because as we know, we are building networks now that are going to provide energy for the next 50 years, and the climate is changing. So we need to take this into account. And we basically brought all this into a software easy to use really for engineers to bring all these years of science and research really into the industry to bring them the tools they need when planning district heating. And this is a bit all the things that today we can cover with digital solution, and many of these steps are still done with Excel, and are still done even with PDF or with really manual inspection, starting from the demand, so how much the buildings are consuming, source identification, so where is the heating and cooling that we can provide to our buildings, the design of the system, so really the pipes, where these pipes are passing, the streets, how to connect the heating to the building, simulation of the system, and finally economic assessment, because at the end, what we all know in district heating, that the economic assessment, the capex and the return of investment of a network is really the main challenge, and what is today probably blocking most of the project. So we cover all these aspects in one place, in really one SaaS, one software, easy to use to get in, and starting with analyzing the heating and cooling demand, in which we have data that are already available for today climate scenario and future scenario. With always, we will see also, I'll present a little case study after, with the increased demand of cooling. So how to take in account in a network of today the new needs of cooling we will have in Europe. Generation of the district heating network, so automatically generate the network, see which are the optimal routes and connection between one heat source and multiple amount of buildings, and dimension everything you need with it, energy storage, sizing the pipes, calculate the pressure, sizing the pumps, really everything that you need at the design level. And then also, of course, generate the output of this analysis, generate scenarios that can quickly be compared and have the most important KPIs for each of these projects, as energy savings, CO2 savings, capex, and so on, and be able to really compare very quickly different scenarios and be able to decide which of the one works better for you, which of the design of the design scenario is more suitable to a certain project or a certain place. Here I have a little demo that I did this morning, a recording of a case here in Geneva, to really show you a bit in action how far, let's say, we can go today with digital tool when designing network. So this is an area close to Geneva, Satigny, a village that is we can see from my window now. We can really select an area and quickly see all the buildings that are in this area, generate a network that connects all these buildings, and quickly generate a scenario in which we can see what is the district today and how is going to look once we connect all this building to district heating, which we can decide very easily the heat source that we want to use, or multiple heat source. We can start to play, remove buildings, add buildings, make scenario, make hypothesis. But all these allows us to very quickly arrive to this kind of result, in which we can really see what is the cost of the kilowatt hour, the total investment, and a breakdown of the different voices. I would like to present you a case study, a project that we did recently, that has been awarded now here in Switzerland for this Infrawatt award, that is really on innovation and replicability. So I think is really the add value of this new smaller network 5G is how we can replicate them and scale them. This has been so far a bit the problem of district heating. Each project was a standalone project, very big, very unique, and despite learning a lot of lessons, every project was very different very difficult to make of this an industry that could really scale and be replicated. With 5G, is instead really going into the direction of a technology that is really turnkey. You can really start from the beginning to the end and have something that is replicable in different places. So I decided to show you this case, because I think it's something that would speak to a lot of you, because it's really like, okay, the case was typical Swiss village, that is not only Swiss village, but could be a typical European village. So 60 buildings, 67 buildings, all with 90% fossil fuel. So there were just like 2-3 heat pumps here and there, most of it oil and gas, very dense with very few streets, impossible to put a heat pump everywhere. They explore different solutions to decarbonize heating and cooling. Is a protected area because it's a village that is UNESCO heritage, so also very complicated to change the buildings. And in a context like this, that was exactly heavily on fossil fuel and with very low also energy efficiency label for each building. So old buildings, inefficient with fossil fuel, a classic. And in this case, we were able, actually, the engineer that worked in this case was able to use our software to really come up with an innovative solution to use all the possible energy sources they had in the village. So really extracting heating from the parking, a little river, ground source heat pumps, geothermal probes. So to really be able to use a different amount of sources all at the same time, all in a network that with low temperature was able to provide heating and cooling. And taking in account also climate change. So this village, this area, actually all the area of the lake Léman here in Switzerland is really affected, like many other places, of course, in Europe, by heat waves and how much the climate is changing. So the need of cooling is really growing very quickly. And he was able to simulate and show what is going to look really this demand of cooling in the next 40, 50 years, and show also, of course, what the account, how renovation rate of the buildings is going to account in this new network. So really, really advanced tool for this case. At the end, the solution they decided to go for was a single tube concept, really for heating and cooling with geothermal probes for thermal storage, also for between seasonal thermal storage, so between summer and winter. And thanks to exactly our software, they were able to use all these different amount of heat source that you see. So there was heat pumps, there was water they were able to heating they were able to recover from the water, heating coming from the parking, solar thermal. So total very, very different amount of sources, all used to provide 100% renewable energy to this village. Of course, this comes with a lot of operational advantages in terms of efficiency, in terms of reducing pumping power. So all the, let's say, the good perks of this kind of solution, 5G. But not only, let's say, operational and technical and design advantages that we like a lot as engineers, but these translated to really real savings and reducing the capex in this case only for the boreholes of almost 50%, with $500,000 in capex savings that for a project like this really made the difference between doing or not doing these projects, with a reduction of the cost of the kilowatt hour, with a reduction of cost in the piping, and with a reduction of cost in the operational cost. So thanks to this optimization, thanks to the possibility of very early on in the design phase have a clear view and understanding of the design choice, of the cost, all this information we're able to really move and steer the project through realization, while most of the time what we saw is in the design phase, when we are not able to make the right choice to reduce the cost, then the projects get stuck and then cannot be realized. So yeah, that's why really we are really hammering and focusing on this 5G solution. We're really now adding a lot of features, also of the software itself, but also a lot of know-how on this solution because we really think it's something that can push forward the development of district heating, and giving the tools to the planners that they need to make these more complex projects. So that's all for me. I try to stay in the 20 minutes, so then we can have maybe more questions and discussion at the end of the presentation of Matteo.
Thank you, Stefano. It was well under 20 minutes. Thank you so much. For those who have a question for Stefano, you can already write on the Q&A box. All the questions will be addressed after all presentations are finished, so at the end of the event, but you can already write your questions at the Q&A box. So continue with the event. Now speaking gonna be Matteo Pozzi from Optit. A brief presentation of Matteo. He's a postgraduate in international relations by the Johns Hopkins University and a postgraduate in quality, environment, and safety integrated management system by the University of Padova. Beyond the academics, he has a vast experience in management and consultancy, especially in the fields of energy and environment. In 2010, he became partner and CEO of Optit, and within this company, he has been involved in the development of some key projects in the energy and utility industry and is currently developing the international positioning of the company, which includes participating in several EU projects. He's also the chair of the DHC Plus platform and the innovation, which is the innovation and research hub of Eurasian Power, and is responsible for the coordination of the digitalization working group. Matteo, you have the floor.
Excellent, thanks a lot. So let me grab, okay, excellent. Yeah, I'm on hold. I believe the presentation of the company and what we do has already been done by yourself, Evan. So I will only point out that before my international relations and management career, I was actually a physicist, which brought me to what the real mission of Optit has always been, which is using mathematics to improve decision making. So we very much like to focus on the decision capability that can be enhanced by tools. And Optit is made of 50 people that try to make this available to companies. We are based in Italy, Bologna and Cesena, with a legal entity in the US, and you will probably discover a bit more why later on. But let's deep dive into okay. I mean, we've been working in DC Energy, I think, since 2011, and since we started, I believe that the initial trends that we saw at the time have only increased their pace and importance. We now see a lot of technologies competing and collaborating within DC Energy systems. We know that one of the key features of DC Energy is the capacity to have a diverse mix, and I would say that every model system is now combining assets that go beyond the second, third generation, as Stefano said before. And once you start to combine CHP with heat pumps with storage, it's easy to say that the complexity to actually meet demand becomes particularly important, and this becomes even more relevant once we look at how prices and costs fluctuate and are unstable due to the increasing importance of renewable sources, which of course make it very difficult to have balanced demand and supply at system level. It is obvious that for systems like DC heating and cooling, how the regulation and how the policies go, but even more important, it is how the drivers are changing. A few years ago, I would say that decarbonization and environmental issues were definitely the driving force behind DC heating and cooling. Today, it's no surprise to anyone to say that affordability and the security of supply are probably more important. Interestingly and luckily, I would say, district heating and cooling is an answer to all of these issues. And maybe it's just a matter of understanding what is the sweet spot between this triangle of objectives you want to meet to make this project work. I would finally say that one of the other challenges is the lack of skills. Complexity comes with the need to be able to master a diverse range of skills that all coincide in the time of decision. And being able to manage this in times of generational takeover, or just the need to bring more people on board because of the sheer growth of the size of systems, that is a challenge in itself. And this transforms into a range of very practical questions for district heating and cooling managers across the whole value chain. And I will, since Stefano, I think, already provided a fairly good overview of what happens at managing demand and distribution networks. I will concentrate my speak on the generation side, both at operational and strategic level, which basically is how to manage all my assets and how to evolve my assets supply mix in order to meet my objectives, which pragmatically coincide with the energy efficient directives targets, or more simply question for better use of local resources to decrease my exposure to global factors and uncontrolled costs. So we're speaking of a solution which looks very much at fourth generation rather than fifth generation, even though the concepts are general to any complex system where a diverse mix of generation assets contribute to the satisfaction of supply. I'm particularly keen on saying that we are looking more at fourth generation because normally the big advantages and the big challenges happen when dimension and scale is actually large. And in these cases, it becomes very, very apparent, and I would say also almost a no-brainer to understand why digital solutions and decision support systems can actually help a lot. This slide is actually just a summary for what I'm going to be showing in more detail. So let me go straight in the details. The core of a digital tool for generation orchestration is very much the capacity to map all the assets, take into account that assets are connected through physical and logical interdependencies. There may be heat that flows from a CHP and goes into an absorption chiller, which may not be linked to other heat sources. Of course, the capacity to capture the technical and economic behaviors of each single asset in the plant is crucial. And of course, this needs to be linked with the fuels and all the inputs in terms of energy that or resources that get transformed into the assets, down to the final demand, which of course is heat and can be a general demand for heat, but also different kinds of heat. We have systems where we actually look at heat at different pressures and temperatures, etc., etc. We have electricity because most normally we will be supplying electricity to a number of dedicated customers, but we will be able to interact with the market, and of course chill whenever there is the cooling factor in the room. So once the system is there, the first requirement to actually meet demand is actually to estimate demand. We developed an application, a module within the application that looks at past data, weather forecast, additional demand drivers in order to estimate demand. This is actually something that normally large companies already have. We don't mind that at all. We can integrate demand forecasting with any third-party tool. Sometimes we are actually asked to compare the forecast that we generate with the forecast from third parties and eventually construct potentially sophisticated ways of having these models compete or collaborate. But we can also just adopt the demand from third parties if there is a trusted source which the company is feeling comfortable with. And this will lead us to the core of the system, which is being able to optimize hour by hour, and today I would say quarter of an hour by quarter of an hour, demand and supply, understanding how the different assets actually need to contribute. The complexity and the how this will happen will depend a lot on the features of what I have available. There are normally sources, and you can see an example of that in the picture here, that comfortably stay at the bottom line of the base load. But whenever you need to understand how to manage storage, and you can see how storage are being used in the green bars, or how to have different machines with different efficiencies interact at different times of the day. That is actually what makes a difference between generating your heat demand with a certain operational margin or a different operational margin. Of course, the key point of all this is that every company needs to plan every day for the next day, because they will normally have to place their energy throughput in the market, which means that every day this decision need to be taken into account. But then, of course, the things happen also on the shorter timescales, shorter or longer, because in fact, very often short-term decisions need to take into account how the plant is going to be running throughout the whole year, which is why we developed models that actually look at optimizing the whole year in order to budget and define the operating strategies with different sources, take into account annual constraints, take into account long-term eventual assets like seasonal storages. And interestingly, the long-term module has now become the core of also more strategic decision making, be it evaluating the impacts of disruptions in terms of price changes, cost, demand disruptions, or just understand what is the impact of new assets in the system. It's looking at the whole year with a good level of granularity and diverse behaviors will help you understand how the introduction of, for instance, storage units or heat pumps will actually work across the high season, middle season, and low season. Most likely throughout the years, the typical variations where pikes in prices or demand can be taken into account. And of course, if they are not in the past data, they can be simulated in synthetic data. In essence, having a long-term module that looks at how the plant is going to be working in a given situation is the perfect element to design long-term retrofitting or investment strategies. But this, as I said, decisions also go back to not only planning for the next day, but also understanding how to manage the same day. And this goes very much in line with the capacity of, and this again is why we like to deal with companies that have a bit of structure. If there is a trading department, what we've seen already and what we've been doing with some utilities is to have their trading department look at district heating system and a portfolio of district heating system as a provider of flexibility. Look at how the markets are going, understand what is the marginal cost of increasing or decreasing electricity throughput by changing the dispatchment pattern, and therefore being able to extra margins on the volatility markets, creating transforming difficulty, an obvious difficulty and an obvious risk for the company into an opportunity to actually be even stronger on the market. And I think this is the real meaning of sector integration, as we see DC heating and cooling being a core for the coupling between markets, which actually is a reality today already. The last addition, which I'm glad to talk about, I mean, you will have seen that there is a number of different analytics approaches behind this, typical model-based optimization, forecasting and data-driven approaches. In fact, the calibration of the plants can be hybrid approaches where data coming from the field and model-based approaches are combined together in order to give the best throughput. In fact, there is also some generative AI and LLM that we are now using to help users understand the suggestion by the system, being able to interact with a machine that interprets the logs of the optimization models and tells you why the optimal path or the suggested path is actually in a certain situation, which may be the explanation of constraints on operations or particular pressure on costs, etc., which makes the solution more transparent for end users to comply with. This is because, of course, the capacity of people to interact with the machine is crucial. In fact, our solution, which stands for Energy Production and Trading Management, interact with and of course goes and picks up the data that are normally managed by the company itself, that are generated by the assets, are generated by the markets, are provided by data weather forecast providers, can get data or feed data back into monitoring systems. The crucial point is to sit on top of the digitalization stack in order to support decision making and hopefully make it as seamless and as comfortable as possible. This actually does happen. In terms of the capacity to really make complex workflows automatic. Nevertheless, I will never stress enough the concept that our tool is a decision support system, meaning it doesn't aim to substitute human intelligence, which will always be there. There will always be human supervision, even though once you understand that your supervision doesn't require your action, maybe we are actually looking at a closed loop AI-driven system. Let me just say that another investment that we are doing is to increase the capacity to look at creating a digital decarbonization and digital evolution pathway, which looks very much at the multi-energy perspective. We've seen and we've come across whenever the scale becomes big, the need to actually look at the DC heating and DC cooling systems as a center between an electric systems infrastructure, which may impose limits on the capacity to actually have access to electricity. There may be bottlenecks in the electric systems that you need to take care about. Heat demand is always very local, and investment costs may need to take into account on not only on the DC heating and cooling system, but also on the potential impacts on other commodities, most likely the energy infrastructure, the electric infrastructure. So starting with projects that look at this problem at very, very high scale, we are now bringing everything together to really have investment planning in a single place, which started from operational, but now is becoming very much strategic in terms of outlook. And this is just to say that when we speak about, everything I've said has been in operation for maybe 15 years in leading utilities in Italy. And I would also say that the solution has evolved as the needs were increasing, coming to the very advanced sector integration examples that I showed before. Nice thing is that energy orchestration is not only for DC heating and cooling. It applies to other large energy-intensive facilities. We have an example that we always like to mention very nicely, which is airports. The Malpensa Airport Energy Center was implemented our tool with minimal changes in a matter of a few weeks, and we are very happy of how things are working. But I mentioned before, we are present in the US, and we are actually using these kind of approaches and tools in order to help the local multi-utility company, Con Edison, understand really how to engage into decarbonization and the construction of a more sustainable New York City in the years to come, which is nice to know since we see all the geopolitical and grand scale. Nevertheless, things are happening, trying to modernize the oldest or one of the oldest systems in the world. First pipes being laid down in 1881. Which is almost 150 years from today. That system is now trying to change its skin in face of the new challenges of modernity. Last remark. Everything I've said may seem complex. It is. There is a lot of complexity, but this complexity is in a way accounted for in the tool itself. So we now have, it's a matter of a few weeks to really understand if and how these approaches can work in your case, which is what we normally have as an impact evaluation, proof of concept, typical kind of projects. And once you've decided, actually starting a provision of the optimization of your supply mix can be again a matter of a few weeks. So it's always a matter for us to understand what are the barriers not to taking this into account. I would say excuses are very, very little because these tools are very much there for you to be supported. So we'll be very happy to eventually deep dive into this with your systems. This leads me to thanking you and giving the ball back to Evan. I went purposely relatively quickly because I think a discussion focused on your actual questions and needs can be more interesting. So Evan, ball to you.
Okay, thank you so much, Matteo. Yes, I invite everyone now, if you have questions, to write them on the Q&A box. While I don't see any for the moment, I have some questions myself. And I would like to first ask to Stefano from Planeto regarding this quote unquote black box of AI, the problem of AI. Because your platform relies on AI for demand modeling and system simulations. So my question is, how transparent are these models for engineers and utilities? And can decision makers fully understand the assumptions behind or they risk relying on a black box, let's say?
Yeah, thank you. It's something that we heard from some of the users, and also we saw it in some of our competitors. Let's say this risk of the black box that I think is not only related to AI but to any kind of model you decide to use. In our case, the models that are defining the energy consumption, the way the heat losses in the pipes, all this is pure physics and thermal energy and physical modeling. So all these assumptions that are behind the equation, the actual equation that we use, are all available, are all clear into the system, in the material that we provide. So it's absolutely something that any user at any time can have a clear understanding of what are the assumptions and how something is calculated. The AI part for us is, again, rather, I would say, a tool in the way also as Matteo was saying before, in the interaction with the software and with this equation. So it's not really a way to calculate anything, because I mean, as we know, it's not that the AI is really inventing anything, or anyway, not energy consumption of buildings that are really very, very much physics based, but it's more the way you interact, the way you can optimize, the way you can compare. So all these things, yes, are more AI, but everything else that comes to the data, to the models, this is really physics that you can see. And this is in terms of black box, not only for the part of the model and the calculation, but also regarding the data. Another problem often is like the origin of the data, how they're generated. And in the same way, in our software is completely transparent, the origin of the data. So you can see what is coming from where, if it is a certain database, if it is a real data, if it is a modeled data, if it's from a certain database, when was updated. Yeah, transparency is really something we value because, yeah, allows engineers to understand the assumption they're doing.
Thank you so much, Stefano. I want to keep on this AI topic now with my question to Matteo as well.
Yep.
Because AI is providing recommendations and optimization strategies, right? So how do you ensure that operators maintain the control and avoid over-reliance on these algorithmic decisions?
Yeah. Well, this is a crucial point. I would say the easy answer is that we are not claiming or I mean, our objective is to provide a tool that can help in operating systems with as little effort as possible, but we never claim to be substituting people. The way we've seen things happening in basically every project has always been creating the capacity to close the loop, but with a level of supervision by the user that will be proportional to the level of trust in the system. And actually, the system needs to build its own trust because it learns from data, and the confidence of the kind of solution that it provides will normally grow in time as the user sees that the need for manual intervention becomes smaller and smaller. I mean, one of the key for Optit has always been, yes, we have the scientific part of building the models, but we also want the softwares to be as clear as possible to make everything seamless. But truly, the last component of our business model is consulting and human beings. I mean, we speak with people, with users, to actually try to make them comfortable with the fact that this tool is something that improves their way of working. What we've seen and what we are seeing all the time is people starting rightly reluctant to give the keys of their car to the AI. And then basically the tool will always help them and allow them to keep their hands on the steering wheel, even though most of the more data intensive and a lot of calculation will actually be suggested. So I think it's very much a matter of not falling into the myth of AI taking over everything, and understanding that in real life with complex systems, the driver will always be at his place, but will be able to use the tools to make more sophisticated evaluations of scenarios, eventually avoid time-consuming operations every day to calculate the pros and cons of switching on a certain machine at a certain time. But this never really creates the risk of finding that the tool has actually overridden you, and the human being is no longer in the loop. The human being will be in the loop as for very long. When it will not be there, it will only be because he's chosen to give the machine full capacity to oversee, just because based on months and years of practice, they've seen that the tool has become completely reliable, which I think is what any user would like to.
Maybe if I can add on this that Matteo was saying, because it's something also we saw very often, exactly, of expanding at the end the knowledge of the user. Because in these kind of projects, they still rely a lot in your own expertise or the one of your team or your own know-how, the kind of projects you've been doing and running in the last maybe 5-10 years. And at the end, the possibility we have now with AI is really just to give to that user that has been doing and seeing a certain kind of project to maybe compare to something else, to have benchmark that are of other projects. So it's really this expansion of knowledge that needs to build up on your own, because otherwise, it's comparison and things that doesn't make they don't make otherwise any sense.
Yeah.
Thank you. Yeah, you want to compliment or? Okay, so I'll actually stay with you, Stefano, because my next question is to you regarding the TESSA platform. Because the platform, it can quickly generate like network layouts, dimension sources, compare scenarios, but also this is the planning part. So how do you account for the real world constraints such as permitting, urban infrastructure conflicts, and of course the acceptance of the other stakeholders?
Thank you. But that's, I think, directly connected to what exactly now Matteo was saying about the replacement of the human and the user in these complex that are anyway touching not only the engineering design decision, but actual life of people. Because I mean, you close a street rather than another. In one street there is an hospital, a street there is a school. So the human factor in deciding ultimately how to develop a certain projects, where to connect it, how to connect it, will always be there. In our case, we are adding more and more level of layers, actual layers of information you can bring to the platform. For example, area in which we just did about the geothermal areas in which you can't drill area because maybe you know that there is a certain area that by laws can be touched, or we have a layers that tells you which are the buildings that you can't touch the facade because are protected. So we do this by layers, adding information. But obviously at the end of the day, when it goes really the project into the streets, deciding where to put the pipe, it will always be the case of at least of an interaction. And a lot of work that we are doing with our platform is also this multi-stakeholder platform to really allow different people to look at the same project, exactly as you would do on Google Maps, and you would say, okay, should we go passing from this street or this street? Basically, we already have like different viewer options, so you can be the one doing the project, but then I can share it with Matteo that can access with his own user and have a look to the project. And our aim is really that this become a co-design platform in which multiple stakeholders from the municipalities, the utility, the engineering office can input in their inputs, like, okay, this street cannot be touched, this one can be done only in the morning, or here we have to, so really to integrate all this information that usually are in the brain of different stakeholders that have different interests. You will always need the input from the real world, but to have them all in one place, for sure, reduce a lot this interaction time that is most of the time is spent in district heating. It's not the actual putting the pipe underground, is deciding which street to close and open to dig. So if we can reduce that one, for sure, it will benefit the entire chain.
If I may add to what Stefano said, I think this capacity of digital tools that are based on the cloud, which means that there can be accessed by different players, is crucial to the extent it lowers the barriers between different silos within the company. It's very typical of engineering and then operations and then maybe the trading department and maybe the management board. Each one needs to have a view on what's going on at network or supply side level. Most normally, since the optimal decision takes into account a mixture of economic, regulatory, technical, and maybe operational aspects, the fact that these tools uh, overcome these barriers and take everything into account is crucial to the capacity of the decision making, which goes back to the the ultimate reason why a machine can help you take a better decision. A plant manager may know very well its plant, but may not be up to date with the fact that electric prices are going rocket high, or they're negative in the next few hours. So having something that actually rings a bell regarding these things and help you understand why things are being suggested different from what your normal policy would be is normally not because people are not capable of doing their work, but because they may not have all the information that the machine can actually integrate. So that's I think this is crucial to the benefits of having digital solutions.
Yeah.
Thank you, Matteo and Stefano. Matteo, the next question is actually to you. About the data integration challenges we may face, because your platform integrates multiple data streams, weather forecasts, plan data, market signals. In your experience, what is the biggest barrier utilities face when implementing such digital twins?
Uh, I would say my a few days ago I would have answered that data was an issue. I'm tempted to say that this is no longer the main problem. There's a lot of data, pretty reliable ones, and I mean every system comes together with a decent supply of data coming from the field, maybe some dashboards. So data is no longer the problem. I would say the cultural aspect of going beyond silos, which I was mentioning before, is maybe the something that needs to be overcome. To be frank, when we speak about adoption of digital tools, I believe that the largest challenge I'm facing is the fact that this is not in the comfort zone of people that will normally use them. That's not always true. There are new or generation of experienced engineers that are embracing very happily the new technologies in the decision making space, but very often the engineering capacity doesn't necessarily goes together with the confidence with what these kind of approaches may lead you. So I would say it's more the correct reaction to change, which needs to be prudent because we're speaking of critical energy infrastructure. We're speaking of a lot of money being managed by these systems. Nevertheless, I believe the digital and decision support, decision intelligence is now becoming an ally to most operators. And I would say that the cultural aspect is more important than the technical one. We're speaking of a mature technology. A lot of data is already there. You already mentioned before the black box aspect. I didn't intervene, but I just shared together with Stefano his view. Nothing that you've seen here between myself and Stefano is subject to hallucination, because that's not the kind of AI that we are employing. We are not on the LLM or Gen AR or the deep neural network domain. We are applying good data management, very sophisticated techniques, but something that relates very easily back to rationale, physical rationales, economic rationales that can be used for decision making. So once this is clear, maybe I mean the capacity to at least try how these approaches work, I think should be a relatively small step for most people.
Thank you, Matteo. Now, my final question is to both of you. I know we've been ping-ponging already, so let's continue like that. And it's regarding the real bottleneck for scaling DHC. Because we know digital tools like we are talking right now, they can accelerate planning and optimize operations. So what do you, Stefano and Matteo, think remains the biggest barrier to scaling up district heating and cooling in Europe? Technology, regulation, financing, or public acceptance? I start with Stefano.
No, I mean, well, I wanted to say to Matteo to start that he is in the field since longer than me.
Okay.
If you
I
have,
can
Yeah, please, Matteo.
break the ice, and then you can build on my answer. Okay, maybe I'm very much biased when I respond. I mean, being Italian, I would say that the largest barrier is neither technical nor based on regulation, or if it's very. I mean, I spoke before about cultural resistance to adopting decision intelligence within companies. But the real problem I see in the north of Italy, which is preventing projects to be conceived, is that most normally the political level is not even considering district heating and cooling as a means to address the challenges that we're having, which, as I said before, a few years ago would have been try to implement the energy efficiency directive. Today, maybe on the security of supply or the affordability aspect. Most normally, district heating and cooling, which requires a lot of parties to get together to try to have demand and supply meet at some point, uh, requires a common vision that district heating and cooling can be an answer, because it is really the technology that can go at the center. It's a hub where demand and supply of different kinds with different technologies can actually meet. But this requires the capacity to work at system level, which is exactly what I'm not seeing in our political class in Italy right now, or very scarce, scarcely available skill. And sometimes I mean, this can be improved also at more general level. So I believe that once the general intention to look into this kind of solutions is there, everything else can be resolved relatively quickly. Not saying that the business plan for this heating and cooling system is easy task, but ultimately the money is there. If you are capable of waiting long enough for the returns to arrive, the technology is very mature. Digital tools are only catalyst for change. They are not the real reason, but they can help in making good decisions, take into account all the complexity that this encompasses. So I think the main lacking point, at least in places like Italy, where district heating and cooling is not common sense that taught in the schools that everyone knows about. Maybe that's the issue. When we speak of more mature countries, things are easier. Uh, I believe the scale up is already taking place because I see a big drive into adoption or consideration of district heating and cooling as a means to increase. And there where the growth curve has already started, maybe in this case, the largest challenge to me is the capacity to actually fill the skill gap of having to look for lots of people across the value chain that can actually help the implementation part. So having enough companies to lay down the pipes, being able to employ lots of new engineers to drive the growth and maybe doubling your capacity in a few years' time. That the skill challenge becomes crucial in more mature systems. That's my easy view of what you mentioned.
If I can add on this, yes, I think, yeah, for sure, it's not the technology the problem. I mean, yeah, we are doing all these digital tools, but yeah, Romans were doing district heating 2000 years ago, so it's definitely not the technology that we are lacking. Is I feel it was true what Matteo is saying. Is really has been, I would say, almost an unfair competition also with existing solution. Unfair competition in the cost of comparing. You know, when we complain, it's like subsidize the airplanes with trains, and with the train ending up costing more, being the most obvious solution. Sometimes with district heating, I feel it's a bit the same. Like it's something that makes so much sense, so much easy, would solve 50% of the war we are seeing right now, and still it's not happening because we are comparing it to the wrong thing, and we are not really taking in account all the benefit of it. So I feel it's a bit this that we are lacking when speaking of district heating, not only to see as a really something to provide heating and cooling, but something that address many topics that goes from the air quality, air pollution in the city, circular economy. So there are so many aspects that should be included in that cost of the kilowatt hour and in the capex you make in the investment, and we are not able to see it, and maybe to show it also. I mean, for people working in this topic, also maybe to have a bit of difficulty in really showing all the benefit of it. Another limitation that I think has been so far in what Matteo has mentioned is very true, this of the stakeholders, because I mean, it's very easy to replace a gas boiler in a single building. More difficult is when you have to speak hundreds of owners of gas boiler with the mayor, and so that's where historically district heating projects so big always public initiated by or the city or the utility, for sure were huge projects, very slow, and we also have to admit not always performing as expected. So the problem of district heating is that in many places we had bad cases. Me, when I was studying at the university doing my PhD on this topic, there were a lot of papers and a lot of projects that were like case studies of showing all the things that went wrong in the realization of a district heating network. So we had also a kind of bad maybe reputation in many places in which things didn't work. Also, we can say maybe that because of the lack of digital tool and a proper design phase that could help in bring this project to be implemented in a better way. But there, instead, these of the new technologies with, for example, this 5th generation, these smaller networks, microgrid, more local renewable, it's something that for sure is going to help to make all these a bit faster, to speed up, because the problem is that if we do only big projects with hundreds entire neighborhood that takes 2 years to get authorized, 2 years to be built, and 10 years before being operational, for sure we're going to miss not only the 2030 target, but also the 2040 and 2050. So reducing the scale and speed up is for sure something that will for sure help. And as Matteo was saying, once this will be more normal, will be more considered. In the same way, now you have to choose between a gas boiler and a heat pump. A microgrid or district heating will be part of the discussion as much as every other solution. And today is not yet in many places.
Thank you, Stefano. Thank you, Matteo, as well, for your answers. I think we are reaching the end of our webinar. Before we finish, I have just a quick announcement regarding the upcoming EHP Congress coming. This time is going to be in Krakow, in Poland, between the 9th and 11th of June. We are all invited to this event, which is one of the most important, one of the biggest events in the district heating and cooling sector in Europe. More than 500 participants, more than 35 exhibitors, many speakers on different sessions about different topics regarding DHC. So it's really an event that you cannot miss if you are in the DHC sector. I invite you to go to our website, which they put on the chat right now, and register for it. Me being part of the project team, I cannot miss this opportunity and invite all of those working as well with projects for the first time, we're going to have a poster area for projects. So if you're interested, you can also reach out to me and my colleagues and learn more about how you can participate with your project at the EHP Congress. Well, I don't see any questions left from the public. So with that, I thank you once more, Stefano Gozza and Matteo Pozzi, for speaking at today's event. I'll give you the floor very quickly for your final considerations. But from my side, thank you so much for joining. It was a pleasure having you two here explaining about your tools and what you do to render DHC more efficient and more sustainable. I start with Stefano. It's okay for your final considerations?
Nothing more to add. So thank you everyone for listening. We will also be in Poland in June, so I can only recommend to all the audience to join. We've been there also last year for the Congress of 2025, and it's been very, very interesting. So for all the people in the field, I think is really probably the only moment of the year to have the chance to a bit discuss of real projects, of expectations of what's happening. So I can only recommend it, and we'll see you there.
Yeah, if I have to make a remark while you were speaking, Evan, I thought that the DHC Plus and Your Heat and Power really is the community which can help people go towards a larger adoption of district heating and cooling, minimizing the risks. We spoke about digital solutions today. In fact, there is a lot of engineering expertise, technical expertise, and this community really brings everything together. I believe that maybe one of the aspects, and I'm saying this because working across a number of European projects, I see the different maturity levels in Eastern markets, new developing markets, etc. Don't be afraid to actually ask to people who have gone through the path, because there's an awful lot that you can learn. And that, by adopting the best practices or avoiding the worst practices, the chances are that the amount of mistakes that you will be making are smaller. So the capacity is there, and there's a great deal of capability on the floor in places like the Congress, but also just liaising with DHC Plus platform. And we are all working the same direction, trying to make things easy so that projects can actually happen, because there is only one imperative. We want to drive this transition forward. We are more convinced than ever that district heating and cooling is one of the key leverages to not only decarbonize, but go towards more secure, reliable, and resilient systems at costs that are comparable, if not better, than other traditional technologies. So we're really looking at something that can only be considered. It doesn't apply to everything. There are still places where electrification is a good answer. but trust me, having a look into DC heating and cooling is always time very well spent if you're looking to move towards the transition of this sector.
Thank you, Matteo. So with this, we end our event, the recording and the presentation. They will be available soon after this event, so you can recap and also check the presentations, remember what was said today. So I finish this webinar, wishing you a good Monday and a good week ahead. Bye-bye.
Ciao, bye-bye.
Ciao, thanks.